Good morning, one and all. In today's lecture, we are to discuss the another concept of stability, that is the subtransient state analysis and its phasor diagram. In the previous lecture, we had discussed the transient state analysis and its phasor diagram. Okay, so difference between the transient state analysis and the subtransient state analysis is only this, that but the duration of that fault and the clearing of that fault after the disturbance should be the occurred. Okay, so this is nothing but the subtransient state analysis. Okay, so what is nothing but the subtransient state analysis? Whenever the alternator is a short circuit, because of the any disturbance or the any internal or the external fault, the current in the all the three phases should be the rapidly rises to the high value of that, generally to the 10 to the 18 times of the full load current during the first quarter of that cycle. Okay, so this is nothing but during the whenever the current should be the rises rapidly, and at within the very the short duration of that time, the flux crossing the air gap should be the large during the first couple of the cycle. Thus the reactance during this first two period is the least, and the short circuit current is should be the higher. Short circuit current क्यों कम हुआ, ज्यादा हुआ? Because the flux is study but the is rises, flux rises हो गया and the reactance कम हो गया, तो ultimately the short circuit current should be the rises very rapidly within the first half cycle of that first couple of that cycle of that short circuit current. This reactance is called as subtransient reactance. ओके, जितना कम रिएक्टेंस रहेगा उतना ज्यादा फॉल्ट करंट रहेगा. कितना? सब ट्रांसिएंट फॉल्ट करंट. दैट रिएक्टेंस इज नथिंग बट कॉल्ड एज सब ट्रांसिएंट रिएक्टेंस, that denoted generally by the x double dash. The first few cycle comes under the sub transient state analysis. Okay, so just we have to discuss the waveform in terms of that. The steady state conditions is there between this period, then there is very but some disturbance of that fault current or the just changing is of that fault current is there, but not the higher one there. The value is generally somewhat greater than the under the steady state condition, but in terms of the sub transient state analysis, the value of that current is study, but it should be generally the 10 to the 18 times as compared to the under the steady state. Means what? The fault current under the sub transient should be the higher than the transient, and the fault current under the transient should be the higher than the steady state. Okay, and what is that about the duration of that sub transient or the fault current? The sub transient fault current duration क्या रहेगा? It should be the higher as compared to the transient one, और transient का पीरियड रहेगा steady state. अगर वो कंडीशन में अगर वो उसको सिंक्रोनाइज नहीं कर पाता है, again retain their position of that synchronization, then the system should be the comes to the under the breakdown or the under the fault condition. Okay, that system should be comes under the unstable condition. That's called as subtransient state analysis. Okay, so in terms of that subtransient state analysis, the reactance play the very important role. That is about the short circuit reactance, which comes under the very few cycles, and it's denoted by the x double dash. What is right about the phasor? Now we have to discuss the phasor diagram under the subtransient state. Under the transient state, the armature winding on and the equivalent were assumed to be the absent in the transient state analysis. But because the equation that we have to use as a starting point, where the derived under that assumptions that all the parameters under the transient state should be the same as compared to the transient state under the steady state. Only the parameter that is dependent, that is the duration should be the higher, and the reactance under the short circuit should be the higher as compared to the under the steady state. But however, the armature should be the present. Armature, that is the armature is should be the present. Their effect should be the following: the sudden change in the circuit condition that lies under the period of the first Q cycle. After that, after which the relation just derived should be the varied. Means what? आर्बिट्यूअर सर्किट का जो भी डिस्टर्बेंस था वो अपन ने निग्लेक्ट किया था अंडर द टू फाइंडिंग आउट द phasor diagram under the transient state, whereas it is not possible if you are to discuss this armature's sudden change in the circuit under the few cycles, then we have to discuss that this armature circuit effect Okay, so and at the instant of the sudden change in the circuit condition, the flux linkage as well as field winding are should be the constant value. But under this condition, the frictionless voltage, that is E double dash, it should be the ED double dash plus J IQ. Transient state में steady state में क्या था? E is equal to ED plus J EQ. But in terms of the transient, that is nothing but the E dash is equal to the ED dash plus JEQ dash. But in terms of that frictionless voltage, the transient, the subtransient internal voltage is equal to the E double dash is equal to the EQ ED double dash plus JIQ double dash, known as the voltage behind the subtransient impedance or the subtransient internal voltage, which are remain constant as compared to the transient one or the steady state condition. Whereas equation similar to the जो अपन ने parameters define किए थे under the transient condition are should be the same, just by replacing the ED should be the ED double dash, EQ dash should be replaced by the EQ double dash, E should be replaced by E dash should be replaced by the E double dash, XT dash, that is but the reactance, the direct axis reactance under the transient state should be replaced by the XD double dash, and the EQ should be EQ dash replaced by the XQ double dash. Means all the parameters the transient should be replaced by that subtransient parameters. Okay, and its phasor diagram under the subtransient state analysis, it's nothing but under the, this is nothing but a subtransient state. Here there is a subtransient is there. Under the subtransient state, under this phasor diagram of the subtransient state, it should be the same as compared to the it should be the same as under the steady state condition. Only the parameter of what the current, only the rapid change of armature current, but V and V should be changed, should be remain, V and the V should change remain constant during the that E and V should be the changes. Okay, so the vector diagram of the synchronous machine under the subtransient condition, it should be the lies with that E double dash should E double dash E क्या है, E double dash is equal to the ED dash plus EQ double dash. It should be the remain constant, but the current, voltage and the E should be changes. That is the phasor diagram under the subtransient condition, where the ED and the ED double dash should be replaced by the ED double dash, and the ID should be replaced by the ID double dash, whereas EQ should be replaced by the EQ double dash. Okay, the angle between that direct axis and the quadrature axis should be nothing but 90 degrees there. Okay, so the angle between the power angle, that is a EQ and the EQ double dash कितना है, that is nothing but the psi is there. Okay, ये हो गया उसका power angle or the load angle, and the angle between the voltage and the induced voltage current is nothing but the theta, that is the power, and that is a फेज एंगल. ये थीटा क्या है, फेज एंगल. ये क्या हो गया, लोड एंगल. एंड ईडी एंड EQ dash and the ID should be the x-axis parameter. IQ dash and the IQ double dash, it should IQ is should be nothing but the quadrature axis parameters. Okay, so this is under the subtransient state phasor diagram. In that case, only the ED double dash should be the remain constant, but during the rapid change of that armature current, during the rapid change of the voltage and the that is a terminal voltage and the induced voltage across the synchronous motion should be the changes. That is the condition for that phasor diagram under the subtransient condition. Thank you so much.